All right, here we are for section 7.4. You can tell we're going a little bit out of order here. It just flows more nicely. So this is on systems of nonlinear equations. So we're going to be looking at the same method, substitution and elimination, but the systems aren't just going to be lines. So 2 learning targets again. The first one says I can solve systems of nonlinear equations using substitution. And the second one is solving with elimination. And then our purpose again, what are we doing? We're solving these systems through group and individual activities so that you can solve scenarios where they come up. So you're going to see one scenario here today where it turns into a system of nonlinear equations that you have to solve. So again, systems are always helpful for solving for data. So here we go. First thing I want you to think about, just so that this makes sense to your brain, is how many solutions can we get when we're talking about things that are not lines. So if we're only talking about lines, picture 2 lines can only do a couple things. They can intersect one time. They can not intersect at all. They can be parallel, or they can be the same line with infinite solutions. But as soon as you start thinking about different shapes, different things can happen. So for instance, if I have a circle and a line, that circle and line intersect 2 times, right? 1, 2. So if I was solving a system that was a circle and a line, I could get 2 solutions. I could get, just like with lines, I could get no solution, right? That would be no solution. I could get 1, so same thing here with a circle and a line. I could get that line bonus points. That line would be called tangent. If we were in person, I'd be asking for your feedback here. So there's 1, 2, 0, 1, and 2 solutions. But picture in your mind, you could get 3. Think about different shapes you could have. Say you had a circle. Sorry, I got a little freeze action there. And a parabola. So we could have 1, 2, 3 intersection points, or we could even have 4. Picture maybe a sideways parabola, switch it up, where we have 4 intersection points. So we can be looking for anywhere between 0 and 4 solutions. I think that's just helpful as we progress to be able to picture a little bit what's going on. So our first method, our first learning target said, I can solve systems of nonlinear equations with substitution. So let's think about what shapes these are. So think in your brain, this first one, what is that? Hopefully you're thinking, well, that's just a line, right? Second one, when x and y are both squared, that's going to give a circle. So if I just think about that, then already I'm thinking, all right, I could get 0, 1, or 2 solutions. That's all I should be expecting, okay? So this is going to be substitution. Easiest way to go is going to be to start with that first equation. And I'm going to solve that for x. Just like I said in the first lesson, show what you need to show. You need to show enough work that I can follow it. But there you can see I did not put plus y because I don't feel a need to. And you don't have to either, or feel free. All right, so now I'm substituting that into the second equation. So instead of that x, I'm going to write y plus 3 minus 2 squared plus y plus 3, quantity squared is 4. That means I really have y plus 1, quantity squared, plus y plus 3, quantity squared is 4. I know that it's tempting to square root, but that's not something that you can do. It's not true. If you want me to prove it, ready? I'm going to give you an example of, not that. That's just not going to be true at all. Hold on. Let's see, 4 plus 9. All right, we all know 4 plus 9 is 13, yeah? But if I wanted to just square root everything, is that going to be true? 2 plus 3 is root 13. 5 is square root of 13. Nope. So that to show you cannot square root across an equation when there's a plus involved. So don't do it. So instead I FOIL. So I'm going to have y squared plus 2y plus 1 plus y squared plus 6y plus 9 equals 4. Combining like terms, I have 2y squared plus 8y Plus a 10 equals 4. You always have to get everything to one side. So 2y squared plus 8y plus 6 is 0. Let's go ahead and take out that 2. Y squared plus 4y plus 3 equals 0. That is quadratic, so I'm going to factor it. You can always do quadratic formula also, but this is a nice factoring problem. So y plus 3 and y plus 1. So I get y is negative 3 and negative 1. So the key here is going to be you want your final answer to be ordered pairs. So you need to keep them matched up. So I'm going to plug in x equals negative 3 plus 3. And I'm going to plug in x equals negative 1 plus 3. I get 0 here. I get 2 here. So when I write the ordered pairs, I got 0 for x. I had plugged in negative 3 for y. I got 2 for x, and I had plugged in negative 1 for y. So you need to make sure that you keep them together. And if those answer bubbles bother you, there it is. Will it move? Ta-da! All right, so that's our first problem with substitution. Here is a second example, a little bit blurry, but let's check it out. So we have xy equals 6 and 2x minus y equals 1. There are different ways to do this. So you could solve that bottom equation for y and substitute in. I'm going to show you a different way because I think sometimes it can be helpful if you have an instance where you get fractions and you might not want to do that. So here's how I would solve this. Again, because sometimes like if you had a coefficient on that y, you wouldn't want to solve and get fractions. I mean, I would assume maybe you're like me and you actually like fractions, but let's pretend that you don't. Let's take that first equation and solve it for one of these. Let me solve for y. It doesn't matter, but okay, I solved for x, so there you go. So x is 6 over y. So now I'm going to substitute this into my second equation. So I have 2 times 6 over y minus y equals 1. So 12 over y minus y equals 1. So, man, Mrs. Stevens, you chose the awful way, didn't you? I would contend not really. A y is in the denominator. I don't like it. Let me multiply through. So I get 12 minus y squared equals y. Get everything to one side. 0 is y squared plus y minus 12. So that turned nice pretty fast, right? So I can factor with a plus 4 and a minus 3. So I get y is negative 4 and 3. Okay. Once I do that, I have that x is 6 over negative 4 and x is 6 over 3. So here I'm going to get negative 3 halves. Here I'm going to get 2. Again, I care that you write the ordered pairs, how they go. So I get negative 3 halves for x when I plugged in negative 4 for y. And I get 2 for x when I had 3 for y. So those are my two answers. When you look at this, I know I didn't talk about the shape this time. That bottom one's a line. Anybody know what that is? Ooh, if you think about y equals 6 over x, that's one of those guys, like a rational. That's what that would look like. So these end up intersecting 2 times, which makes sense. You know, you think about a line. Could hit that twice very easily. All right, so those are our 2 examples for substitution. Now on to elimination. All right, here is our learning target number 2, said I can solve systems by elimination. So why did I not use elimination, say, for this? Check that out. There is nothing to eliminate. There are not common terms between those. The first problem, why not elimination? Again, what could I add or subtract and get rid of? So look how this one's different. Could I substitute? Certainly. I could plug this x squared plus 3 in for y, but then I'd square it. So I'd be up to a 4th power, which can get pretty feisty. So instead, here's what I'm going to do. I'm going to take that equation. I'm going to subtract over an x squared to the left-hand side. So I have negative x squared plus y equals 3. Okay, what that means is I add these together, those cancel. These, don't you add those, you can't add them. You get y squared plus y, and it equals 12. So now I can do y squared plus y minus 12 equals 0. Y, I'm going to get a plus 4, a minus 3. So y is negative 4, y is 3. So if y is negative 4, oopsie daisy. And I'm going to come over here because y is now 3. All right, so check out what's going to happen because this is going to be a little more interesting. I subtract the 3 over, I get 0. Can I square root 0? You should be saying yes. Yes, you can. So I got 0 for x when I plugged in 3 for y. Okay? Over here, I subtract my 3. I get negative 7 is x squared. Square root, oh, if I want to be really fancy, plus or minus I root 7. Whoo! Okay, but we are looking for real answers, so that does not count. So this has one real solution. On a graph, let's think about our graph here. This, think about that, just x squared, parabola. This, x squared and y squared equals 9. Nice circle with a radius of 3. They only intersect at one point. That means they're tangent. It's actually that top point right there. Picture that's a parabola shifted up 3. So they intersect right there. That's kind of cool. So these non-real solutions don't count. But notice, if this had been a real number, notice my plus or minus. That would give me 2 separate points if it had been real. I would have had to do, say root 7, comma negative 4, and negative root 7, comma negative 4. So keep that in mind when you solve, that when you square root, you get a plus and a minus. All right. On to an application. Okay, what I want you to do, I want you to read this. I want you to try to set it up and solve it and see what you get. Okay, so pause this. I'll put up the answer in a minute, but I want you to try to work through, create your system, draw a picture, create a system, see if you can solve it and get the answer. All right, hopefully this is what you were thinking. You have that division into 2 compartments. So we have our 3x plus 2y. If you called this y and you had 3y and 2 x's, your solving would look a tiny bit different, but you would end up with the same answers. So you can see my system. You can see here is an example where I wanted to solve here. I didn't want to solve the top equation because I didn't want to create gross fractions to deal with, but that can be personal preference. And you solve through, feel free to check your work against mine. And we got that x is 6 and y is 9. Okay, nice job. And if you want to try one more system where you can choose substitution or elimination, feel free to try this. So go ahead and pause it and try it. And then here with your square roots, you would have gotten 4 answers because you square root, you get plus or minus your 1 and plus or minus your 3. So you have to make sure that you found 4 solutions there. These are 2 circles. They're not actually 2 circles. This one's a circle, that one's an ellipse, which is how they can intersect 4 times. But So 4 answers there, looking at your combinations with the square root. So be careful that you actually look at all your combinations. If you want to see that work, I'm about to run out of time on my video. One moment, please. Here's the work for that. If you tried that problem out, you square root, you get the positive and the negative one. So you have to plug in the 1 and you get plus or minus 3, and you get plug in the negative 1, get plus or minus 3. So that's why you do 1 with 3, 1 with negative 3, negative 1 with 3, and negative 1 with negative 3. All right, my time is up. Please go do your homework and join me on Zoom if you need to.